Waves are transverse when the direction of oscillation of disturbance is perpendicular to the direction of propagation of energy. Polarization is a situation whereby the oscillations in the transverse wave is restricted to only one direction, in the plane that is normal to the direction of propagation of energy. At the displacement antinodes, the wave has maximum amplitude and the send is pushed sideways by the sound wave. At the displacement nodes, the wave is stationary and the heaps of sand settles here, creating heaps of sand at regular intervals. Distance between adjacent heaps of sand equals half a wavelength. Hence, there are 2.5 wavelengths in 39 centimeter. Therefore, the speed is 334 meter per second. A stationary wave is formed when two identical waves of the same amplitude, frequency, and speed but traveling in opposite direction overlap with each other. In this setup, the incident wave and the refracted wave of the closed end of the tube superpose to form the stationary wave. The speed calculated is the speed of the incident and refracted wave. In other words, it is the speed of the sound wave in the tube.